Hello everyone, this is Suresh here. In this session, we will look into the preparing prepare data for ML APIs on Google Cloud. So in this course, we have multiple labs, about 10 labs. In this first lab, we will start with the first lab. So in this lab, we will use Vertex AI Quick Start. So basically, in this lab, uh, we are going to complete the tasks that is assigned to us. There won't be any technical or any theoretical discussions over the concepts. It is only for a lab session. So without any delay, let's get started. So let me do the setup. Let me agree to all the terms here, all the terms and services, conditions, everything. So if you see in this lab, at any point in time, you can pause the video and go through the content over here. So this gives us an idea about what is the BigQuery, what is AI, and you can see some information about it. Okay, and in this lab, the objective is to train a TensorFlow model locally in the hosted Vertex AI node and use the TensorBoard, Vertex TensorBoard visual model. So this is the step just a few minutes ago we just completed. So let's see if there is any pending. Okay, temporary open user student ID is the same. We don't find any issues. Let's say password. Basically, we did everything. So let's activate the Cloud Shell. So you can see it in top right corner. Click on Cloud Shell. Let me close this for a better view. Click on Continue. Just give it a few seconds. Okay. Now we can see the lab name. We know this, and also this matches with our project ID, and also you can see the same in the dashboard as well. You can see the dashboard as well. So this one will match us here for the student. Okay. So let's execute the optional list just to authorize Cloud Shell. And also we'll double check on, this is also an optional. So double check on the list of project assigned to us. So this is the project. So we can say this here. Okay. This is what we did. Open the Cloud Shell terminal by clicking on Cloud Shell icon. We did this and okay. So here we will enable the Google APIs, whatever is needed for us. So you can see compute, IAM credentials, monitoring, login, notebooks, AI platform, BigQuery, artifact registry, cloud build, and container. So all the APIs we can enable. You can also see okay, this operation is successfully finished. You can see this here. So to double check on that, you can click the progress. So you can see, just give it a few seconds. This is what they say. So few minutes. So without any delay, let's move on to the task two. And again, we will check the progress. We'll come back and check the progress. So we'll navigate to Vertex AI, navigation, Vertex AI, and here enable all, close this, and you can see enable all recommended API. You can see the APIs is getting enabled. We have the activities and now let's check this. Looks good. Okay. Now, uh, for a better view, what I will do is like I will take this into a new window. I'll go back. Yeah, I'll come back here and I will close this. Now we have a better view. Here, after enabling, click on the workbench. And step 4, you can see instances and click on create new. Okay, and let's start with the configuration. So let's configure saying lab workbench. We already have the central one and the zone should be central 1C, and we will leave the rest as optional. If you want to see, you can continue. So what I will do is like I won't change anything, but I will click on continue, and you can see the environment. Environment looks good. The default values, and next is a machine type. You can see the default machine type is E2 standard 4, which is having 16 GB of memory. And click on continue, and this is about the disks. I will leave everything, and this is for the networking, and this is the setups for IAM and security system. Let's click on create. So what it does, it will take about 2 to 3 minutes to get created. So once created, we'll check. So here we can see one open Jupyter lab. This is what it is going to get displayed in a few minutes. Okay, you can see this is still in progress. So we can go through and see how the configuration is going on. So you can check on the logs if need. So this status provisioning changed. Maybe you might see that provisioning changed to initialization. You can see the logs as well. Again provisioning. You can see the logs if needed. Okay, now this changed to active. Okay, we are good. So as they displayed in the left side, you can see Open Jupyter Lab. So now select the Open Jupyter Lab. It is going to open in a new tab. You can see the terminal 9, step 9. Terminal is opened. We got, let's check the progress as looking good. So task 3, let's copy paste this. Let's clone the repository. This will take about less than a minute to get the repository completely cloned in our lab workbench workspace. So this will take less than a minute. Let's give it a test. So this is completed. Now let's go to the task 4. In the open terminal, run the following commands to install the lab dependencies. Okay. So here you can see it is moving to training data analyst, self-paced lab, Vertex AI, Qwik start. So that is the same structure. You can see it over here. Training data analyst, self-paced labs, Vertex AI, okay, Vertex AI, and Vertex AI Qwik start. Here we have it. Okay. So and also there we are going to install the all the requirements. Okay, if you are interested, you can just go through that, select this requirement and see what the requirements are. So this is about this file. Okay, so these are all the packages it's going to install. And also if you know this sudo apt pandas3 and graphics and open PyExcel install. Okay, now let me close. Let me go back to the starting point. Okay, now I will copy this command and paste it over here. Enter. So let's see when prompted why this enter. Okay, so what I would suggest is in the meantime, we can run the lab node. We can navigate to this location in the task. Okay, basically training data analyst, self-paced labs, Vertex AI. So this is the navigation. So Vertex AI quick start and what lab the exercise. So I have opened the lab exercise. So again, you can see the lab exercise here, and the terminal is still in progress. I will wait for that to complete. Here, this is where uh, our tasks are getting completed. So the only objective here is from this point, we are planning to execute this lab session. Okay, so in the meantime, the progress continues. Let's see what is in the lab exercise. So in this lab exercise, so I'm not going to get into the details of this exercise, but I suggest you to uh, pause the video and read through this, or else what you can do is like you can clone the repository which is already provided, which is already there here at this step. You can clone the repository to your personal machine or local system, and then navigate to the specific file, and then go through at your convenient time. So my objective in this lab is like only to execute it, okay, execute the steps. So for whoever is wanted to go through this video, you can pause the video and go through the text, go through the content. So this is about the introduction about a CLV prediction in BigQuery and TensorFlow on Vertex AI. This gives some information about the predictive CLV and some graphical representation about all this. So in this session, we are not going to discuss about what it got predicted and what is the insights about it. So that is not the objective of this session. Okay. So without any, uh, so let's move on. Let's see whether the process is completed or not. Here, let's complete it first. Okay. Now looks good. So the process is coming. We got the prompt back. Okay. So let's start with this path. So hit enter. Replace. Okay. In this step, you can see retrieve and set project ID into it. Okay. This is getting the retrieving the project ID and the region. So region is UVS central one. This is correct because you know that we selected the user central one. So we should be good with this. Shift enter, and you can see the project ID. So if you want to see the project ID, what you can do is like you can just see the project ID. You can see this is the project ID. It will get printed. And setting up the GCS bucket. If you want to print the GCS bucket also, you can see. Shift enter. You can see the GCS bucket has been. I mean, right now it is just name has been assigned. So this command gsutil make bucket in the specific region is coming from the above, and the bucket will get created. Okay. Again, I'm not going to give very much detailed in this all the session. I'm not here will be very much detailed or comprehensive session, so I'm just doing the high level only to execute the code. Okay, so next importing this code. I mean importing the packages and the necessary libraries needed to execute. And okay, yeah. So kernel is busy, so let it complete first. Okay, now this is done. Now initialize the Vertex AI. So this is the command to initialize the Vertex AI in the AI platform in Google Cloud. Here, I will leave it to you guys. You can pause the video and go through what this data set is, what is the citation, what is the data ingestion, and those things. Okay. Now, BigQuery constants, I'm leaving, so they are asked to leave us unchanged, but this is how the process data will get processed. Okay. Hit enter. The Python script will take 2 to 3 minutes to download and process the live data file. Follow along with log and out. Okay. So, hit enter. So what basically what it does is this URL, in this URL, this data is going to be collected and then getting it downloaded. So if we are downloading it, Python utils, you can see there is a one data and utils is got everything is got created by the okay. So this one I will leave it until the kernel gets idle. In the meantime, you can go through this uh, data processing steps. So this is a lot of information is provided here, and what are the features and what is the target. So you can see that there are about 1, 2, 3, 6 features and one target. Everything is in numerical. Okay, almost 5 is in numerical. Sorry, 6, 5 in the features are numerical and one is categorical. The target is a numeric. Okay. Now you can see this is the information. This lab demonstrates simple way to use DNA, deep neural networks, predict customer 3 month ahead CLV monetary value. So if you follow along from the beginning, you might have been better understanding about what this data processing and what are we planning to predict. Okay, I think this all the initialization and everything is done. So the way are looking good. So data processing is, I want you to stop the pause the video and finish the reading. And also, let's move on to the EDA in BigQuery. So this is where, okay, so how recent customers have purchased. Okay, we have some since last purchase, and we have some information about it. Query successfully executed. Now let's see the describes and let's see the it in the bins. So basically graphical representation of how. So you can again pause the video and go through this interpretation or inference from the graph. You can go through this readings. Again, I will go back here. Okay, now let's see the frequency, number of purchases. Similarly, you can see the description of the purchases and the histogram of the purchases. You can see it. Again, I leave it to you for what I would say for the inference or the understanding. Now let's see the customer spending in respect to monetary. Query is executed, monetary, and the plot has been defined. Again, I'm not here to explain the table or the graph chart here. You can go to this. Establish a simple model performance baseline. What I will do is minimize this. We don't need that. So we can have a better view of it. So again, I recommend you to pause the video and go through the code if you are interested. So at this point, I'm not going to explain this. So if I explain this, my lab time will get exhausted. Let me hit enter. So you can see the MAE, MSC, and RMSC. So what this matrix is, you can go ahead and research it. You can learn. I recommend you to learn. Next, you should look for the plot-based linearization to get sense of opportunity areas. Okay, opportunity areas. So now shift enter. Now baseline head, we'll see. So there is a customer ID, predictor monitor value, and target monitor value. So and now we will see this in the plot. Okay, now moving on. So train a TensorFlow model locally. Online retail, test, train, and validate. So you can see the split. It's like training is 60, 20, 20, I guess. Okay. Now you can see train data split, dev data, and test data. So the validation data and test data. The split has been defined. So now we have the actual training parameters. Now you can see training examples. Stop point at 20, batch size is 32, number of checkpoints, number of epochs, and all the features that we needed, and the label. Label is the target. Okay. Now let's start the training. Shift enter. I mean, defined it. Transform pandas data frame to TensorFlow data set. So this is the definition file. Now again, training the train data set, dev data set, that means validation data set and test data set. So we are pitching it. I don't know what this sudo driver is. Sudo driver failed to call internal driver. I don't know whether this is going to start an issue. Let's see. Let me run the next query. So here, this is the RMSE metric and the building the model. So you can see the input layers. Let me first start with the execution. We'll see. Now we have the input layers defined, number of hidden layers 20%, and you can see all the information. You can pause the video and you can see the model. You can see the optimizer, Adam optimizer, and MEA kernels. Okay, I want you to understand this model. Okay. So this is the graphical representation of the model. Now TensorFlow board model PNGs. You can see it over here. Now weights, checkpoints, callbacks, everything has been defined. Now history. Now you can see the epochs 1, epoch 2, epoch 3, 10 epochs. You can see root means bad error. You can see it is getting increased. And also if you want to see by only 7 checkpoints, okay. I think there is now for the loss column. There were 7 epochs and you can see the loss and value loss. Now the data prediction. Training results, and you can see to NumPy and all. You for this you need to have a very good understanding on the NumPy and the data frames of Python. Okay, so if you understand that, this is very easy to understand. And now model prediction calibration plots. There is a figure defined, training results plot has been defined, training limits has been provided, again plot for the AX. Okay, this is a very big code. I suggest you to pause the video and go through the code. Now shift enter and you can see the graphical representation of this. So again, there is a lot of improvements can be done in this lab, or you can, there is a lot of opportunities to get trained and to better understand this in this lab. But unfortunately, the lab is only provided for 45 minutes. So basically, the main objective of this lab is not to get into this model, how to develop a model and all. Basically, how to use the Vertex AI and how to launch instance, and in that instance, how to install the packages. And once the packages were installed, how to execute the or how to develop a code and how to run it from the BigQuery and virtual BigQuery data using the Vertex AI. Basically, that is what the intention of this whole exercise. So now we know how we train the model in the local Vertex AI notebook and how to use the tensor board. So both objectives has been completed. So don't think that I have not explained any of this the code and all. This session is the objective or the session is not that. Yeah, the objective is to use the web Vertex AI and execute the code in the workbench. Okay, this is how we will do it in the Google Cloud. So this completes the session and thank you for joining. Have a great day. Bye.